Welcome back, students. Today we are going to talk about the graphical representation under the chapter motion. Okay, so we have dealt with a lot of graphs maybe earlier in mathematics or in another maybe topics like science only. So these graphs basically they gives us the better representation of motion that literally can show us that how something is changing its acceleration or what speed it is going or how much distance it is covering. So that's why it is important to understand or study graphical representation of motion. Okay, so let's quickly dive into the section without wasting time. Okay, so to start with, we know that motion is there, right? And motion can be represented graphically, like I already told you. Okay, so there can be two graphs, okay, which can be made, and that is distance time graph, where you will be representing distance on the y-axis, that how much distance something covered, and time on the x-axis. Okay, you do know that what exactly x and y-axis, right? This is the y-axis, this is the x-axis. You do have to mention it when you are making a graph, otherwise you might lose marks in your exams. Okay, now illustrate an object's position relative to its starting point over time. So for example, suppose this is 10 meter, 20 meter, 30 meter, right? In 5 seconds, 10 seconds, 15 seconds. So if I draw a graph like this, so that means in 5 seconds, the vehicle covered 10 meters. Okay. In 10 seconds, it covered 20 meters. Okay. So this is how it can be represented. Another is velocity time graph. So this shows how object's velocity changes over time. That means it was first 5 meter per second it was moving, then started moving 10 meter per second. Okay. So this will be shown in the velocity time graph. Now to understand it better, let's just go to the another slide quickly. Okay. Now, first we'll talk about the distance time graph. Okay. So let me just take the annotate. Okay, yeah. So it shows how an object's distance or position changes with respect to time. This I have already told. The significance of the slope. So what exactly slope is? If I'm making a graph like this and this is the slope. Okay, if I'm making a graph like this will be my slope. Okay, if I make it like this is the slope. Okay, you understood, right? So slope of a distance time graph or represents the object's speed. That means you have taken distance, right? Distance is on the y-axis. On the x-axis, you have time, right? So what happens is, if you are moving it like this will be your speed. That means you are moving with this speed, right? You are covering this much distance in this much time, this much distance in this much time, right? And speed is nothing but distance upon time, no? Right? So distance upon time, distance upon time. That means this much distance, this much, and time, how much? This much. Okay, this much is just an example. Okay, so let's take like 10, 20, 30. Let's take 1 second, 2 seconds, 3 seconds. So in 3 seconds, if something is going 30, traveling at the path covered is 30 meters. So the speed would be, or the velocity here would be exactly 10, right? 10 meter per second. Understood? So this 10 plus 10 plus 10, right? 10 meter per second. Okay. Now, now the straight line indicates the uniform speed, meaning the object covers equal distances in equal amount of time or intervals of time. So basically, in every like 5 seconds, if my graph looks like this, so every 5, 10, 15, 20 seconds, okay. If the graph is like a straight line, the slope is like a straight line. So that means every 5 minutes, I'm covering, let's say 10, 20, 30. Uniform speed is there. That is what it means. For a curved line, it says that it signifies changing speeds. For example, I made something like this. The graph looks like this. So maybe here the speed would be, more increasing. Then at a certain point, it becomes maybe less. Okay, or in a particular time it becomes less. Okay, so this much distance is covered, but in this much time. More distance in less time. Okay, so curved line signifies the changing speed. Here the speed wasn't being changed, right? It stays same every 5 minutes. But here at every 5 minutes, you will see a major difference. The slope is in curved shape. That's why. If the line is horizontal like this, so this is distance, this is time. Now suppose this is 10, this is 20 meter, right? And here time is 10, 20, 30. Okay, or 1, 2, 3. Let's take 1, 2, 3. Okay, 1, 2, 3 seconds. So in per second also, the distance was only 20, right? In second also it's 20. Third second also it's 20, right? That means the vehicle is, or whatever we are talking about, the object is not moving. It is stationary. It is staying at one distance, one position. It is not in motion. Okay, so that means it is at rest. Okay, so for instance, if a car travels 60 kilometers in 2 hours, its distance time graph would show distance on the y-axis and x-axis with a straight line connecting the origin points like 2 and 60 kilometers. So we can make something like this. Let me just make it. If we make it like 10, 20, 30, 40, 50 and 60, let's say here, and let's make 1 hour, 2 hour, 3 hour. So it will be here. Okay, the distance would be like this. In 2 hours, it's reaching 60. That means in the first hour, it will reach 30. See how magically it appeared, right? Immediately you can tell. Okay, at 0, it was at rest. It wasn't moving. Okay, clear? I hope this is clear to you. If any doubts, you can ask me, okay? Right. Okay, now distance time graph. So again, I have told this, I don't have to go in the depths of this. So straight line means constant uniform speed is there. Curved line means the speed is increasing, accelerating over the period of time. And horizontal line means it's 0. Okay, so it's at rest. It's not moving at all. The object is not moving. Okay. Now coming to the velocity time graph. Now the velocity time graph, if you will make, you will take the velocity on the y-axis and you will take the acceleration, the time on the x-axis. So let's take velocity. Okay, let me just make a better graph. Okay, this graph is there, no? We'll use this. Yeah, so this is velocity, okay, here. And this side is, this is y-axis, this is x-axis, this is time, right? Now, what happens is you will see a slope. That slope tells us that what is the acceleration. That means, because see, this will be our initial velocity, let's say, if we are starting from here, and this will be our final velocity if we are stopping here, right? So v minus u upon t is only acceleration only, right? So this will give us the acceleration of an object. So slope of a velocity time graph gives us the acceleration of an object, right? And area under a velocity time graph represents the object's displacement. Okay, so the area under this, whatever area it can cover, okay, that will give us the displacement. That means how much distance has been traveled. Okay, so horizontal here line again would tell us that the velocity is constant. That means it is moving with a constant velocity if the graph is like this. Okay, so there is no acceleration. That means it's not moving with another speed. Okay, the speed is not changing. The acceleration, velocity is not changing a lot. It is constant. The sloped line represents the acceleration. I have told you already. A positive slope means increasing velocity, while a positive slope looks like this. So velocity is increasing here, but a decreasing velocity slope looks like this. That means at this time also velocity was this, at this time also it is this, and then here it is reducing. That means you have put a brake. And that's how, like, if you are going with a 50 kilometer per hour, imagine that, right? So 50 kilometer per hour you are going. If you accelerated it, you went to 60. So the graph, the slope looks like this. Now, if you have put a brake, So it started to come into a very slow velocity, right? Around maybe 30 meter per second, right? So here you will see a decrease in the velocity. Now, line along the x-axis signifies the object at rest or zero velocity. If here the line is somewhere, so it will be zero velocity, no velocity, this axis. If the line is here, matching to the x-axis, okay? Okay. Now, so here again, velocity time graph, you can easily tell that horizontal line is zero, no displacement, right? Positive slope is if acceleration is more, right? So increasing velocity will be there, and negative slope is if acceleration is less than zero. Okay, if you are putting brakes basically. So that is decreasing velocity. That means object is basically slowing down. Okay, now if we compare, these two. So at y-axis, we keep our distance in a distance time graph. In a velocity time graph, we keep on y-axis a velocity. Okay, the slope of distance time graph gives us speed. The slope of velocity time graph gives us acceleration. Area under graph. So here, not typically used for kinetic, no use if I make a distance time graph like this, right? So this area is not much useful. But here, if I take velocity time graph and there is a slope, and we can use this area to figure out the displacement. Okay. So to understand this, maybe this can be a little bit difficult. Okay. Because again, there are a lot of numericals and questions and, new topics are there. So if you have any difficulty, you can feel free to ask me. Okay. Now these questions you can, just try at home and try answering in the comment section. So question 1 is, in which graph is the slope equivalent to acceleration, distance time or velocity time? So here there is a trick, you can find the answer also, but again, let's see whether you can or not. The second question is, a horizontal line on a distance time graph indicates what about an object's motion? Uniform speed, or is it at rest? And the last question is, the area under a velocity time graph represents which physical quantity? Is it speed or displacement? So I think you can take a screenshot or maybe just pause the video and try solving these. Okay. And with this, thank you so much. Keep exploring, and you can go to my Urban Pro profile to check out more videos and